Do you want to build a network of wireless sensors using ESP32s and ESP8266s all mixed together? In this lesson, I'm going to demonstrate using ESP-Now with ESP32s and ESP8266s. What I'll show you is a way of taking an existing sketch that's used with ESP32s and change it, make some simple modifications so that you can use it with the ESP8266s. This example sketch even comes pre-installed with the Arduino IDE when you get it set up for using ESP boards. By the end of this lesson, you're going to know the exact sketch that I'm talking about and the tiny changes in the sketches that are going to make all the difference. Let's go. Well, before we dive in, I'd really appreciate if you could take a moment and click that subscribe button. It doesn't cost you but a click, but it really helps us grow our YouTube channel and bring you great content like this. Also, if at any point while you're watching this video and you're thinking like, what is this guy talking about? Please take a moment and ask a question in the comments. I do my very best to answer all the questions I can. All right, so let's jump into this. First off, I want to make sure that we're on the same page. I'm assuming if you're watching this, you know what an ESP8266 and an ESP32 board is. But if you don't, just real quick, these boards are Wi-Fi enabled microcontrollers made by a company called Espressif. They're super cheap and they can be easily programmed using the Arduino IDE. For this reason, they've made a huge splash for newer folks who want to build really cool wireless applications for hardware devices without some huge learning curve. So those are what ESP boards are. You probably already know that. But what is ESP-Now? You might be thinking that since we're talking about all these cool Wi-Fi enabled microcontrollers, that ESP-Now would have something to do with Wi-Fi. But actually, ESP-Now is a different protocol developed by Espressif, which enables multiple ESP devices to communicate to one another without using Wi-Fi. It's a wireless protocol that's similar to like a low power 2.4 gigahertz wireless connectivity that is often used in wireless mouses. Using ESP-Now, you can design a network of ESP devices that can communicate in a huge variety of ways. For example, you can set up a network so that you've got a transmitter transmitting to one receiver, or you could set up a network where you have a transmitter transmitting to multiple receivers, or you could have a bunch of transmitters transmitting to a single receiver, or, it could be like a cocktail party and everybody's just talking to each other. Now, what I'm going to demonstrate is having my ESP32 transmitting data to a bunch of different receiving ESP8266s. So just for example, what I have here are 4 different ESP boards. This one is an ESP32 SparkFun thing. This one is an Adafruit Feather Huzzah ESP8266. This is some Wemos D1 Mini knockoff clone. And this is an ESP8266 12E module by Node MCU. This is like a little gang of ESP boards that were causing trouble in my drawer. So I'm like, all right, I got to do something useful with you guys. Now I have these set up so that when I press a button on the ESP32 thing, it sends the state of a digital pin to the connected ESP8266 devices. And it turns off the LEDs. So, this is like a trivial example. But you could imagine a situation where a setup like this could be pretty useful. You've got one central transmitter, and it's going to push out, a message to a bunch of different receivers. And what I want to show you is a sketch that comes pre-installed on the Arduino IDE that is designed for the ESP32, but we can modify it pretty simply so that it works on ESP8266s. And I really think that this is a great starting point for getting these two boards to work together. All right, so here we are in the Arduino IDE, and I'm going to be using Arduino IDE 2.0 for this lesson. You could use Arduino IDE 1.0 just as well, or VS Code, or whatever IDE you want to use, but there's some certain features of the Arduino IDE 2.0 that are kind of useful for demonstrating some of the ideas here, so that's why I'm using the 2.0 version. Now, I want to point out, the sketches I am about to show you are not going to show up unless you have already installed the ESP32 core in your Arduino IDE. In fact, if you want to work through this, you're going to need to install the ESP32 core and the ESP8266 core in your Arduino IDE. It turns out to be extremely simple, but we've already covered that in other lessons, so I will link to those lessons in the description. So if you're not sure how to set that up, just go to the description and you'll have it set up in like 2 minutes flat. Okay, so the first thing we're going to do is connect an ESP board to the computer. Then I'm going to go to Tools, Board, and I'm going to come down to ESP32, and I am going to select the model that I'm using. So right now I'm using the SparkFun, see if I can find it, SparkFun ESP32 thing. So I'll go ahead and select that. Now I'm going to go back up to Tools, down to Port, and I'm showing a list of ports. Now, you might have a really big list of ports and it can kind of get confusing. And depending on the development board you're using, sometimes there's like a human readable port name in the list. For example, I'll just go ahead and let me hook up an Arduino Uno. When I hook up my Uno, it'll take a second to show up. I go to Tools, Port. You can see that it's marked with Arduino Uno. So, hey, that makes life really easy. But a lot of these boards, they just have some, stuff like that that really doesn't mean too much to me. So chances are you're going to feel like Gollum trying to guess what's in Bilbo Baggins' pocket as you're trying to figure out these ports. So one strategy is just to disconnect all of the boards that you have connected to your computer and then see what's on the list and then just connect one of them and see what gets added. And then what gets added is usually what you had connected. So anyway, this is the one for my ESP32. I'll go ahead and select that. All right, so now we have the appropriate board and the appropriate port selected for our ESP32. So now what I'm going to do is go up to File, Examples, and I'm going to come down to ESP32. Notice that this says Examples for SparkFun's thing, ESP32. So depending on the board that you select, you're going to see different examples in this section. So I'm going to come down to ESP32, ESP-Now, and then there's 2 folders in here. One is called Basic, and one is called Multi-Slave. The one with Basic has a master and a slave, and the Multi-Slave also has 2 sketches, one for master, one's for slave. So the master sketch is the transmitter sketch, and the slave sketch is the receive sketch. In today's example, I'm going to work through the multi-slave example. Now, in a previous video, I went through in depth how this basic example works with ESP-Now. And so if you're kind of new with ESP-Now, I think that video might be super helpful for you, and I will make sure to link to it in the description. But both of these options, basic and multi-slave, are fantastic places to start when you're trying to figure out this ESP-Now. They're just rock solid examples. In fact, my recommendation is that you would use these sketches as like your boilerplate code when you start developing your projects for ESP-Now. Okay, so what I'm going to go ahead and do is I'm going to upload the master sketch right here to my ESP32. So this is one Arduino IDE window, and I've got this master sketch opened in it, and I've got the ESP32 selected with that appropriate port. And again, if you're curious how this sketch works, check out that other video we did where we kind of walked through and boiled down a lot of this stuff. But here, really, I just want to show you how you can get ESP32s working with ESP8266s using ESP-Now. Okay, so I'm going to go ahead and upload this sketch to my ESP32. All right, so I've got that uploaded. Now what I want to do is plug in one of my ESP8266 boards. So I'm going to go ahead and plug in that Adafruit Huzzah. Got that plugged in. And what I'm going to do is open a new IDE window. So I'll just go to File, New, and I'm going to go through that same rigmarole of, selecting the board and the port. All right, so I've selected the ESP8266 board that I'm using and the appropriate port. Now, this is where things kind of get interesting, right? Because what we want to do is we want to set up ESP-Now on an ESP8266, right? And when I go up to File, Examples, and I see examples for Adafruit Feather, ESP8266 board, and I come down, there's nothing in here that jumps out as far as like ESP-Now, right? Like there's no, I don't see a similar example for using ESP-Now in here. Maybe I'm not looking close enough. Maybe it is in here, but I've kind of searched around in here and I never really saw one. There is this Wi-Fi mesh, right? And this one says, hello, ESP-Now. But, when you take a look at it, it doesn't appear to be using, at least directly, the ESP-Now library. So this isn't really what I'm looking for. So here's what I'm going to recommend. What we're going to do is we're going to come over to this other window right here where we've got our ESP32 connected. We're going to go to File, Examples. We're going to go down to that ESP32 example. We're going to come down to ESP-Now. Here's that multi-slave, and we're going to go to the slave example sketch. We're going to open this up. Then we're going to copy this code, or I suppose you could save as, but I'm just going to copy that, and I'm going to paste it in here. So this is code that was written for the ESP32. And what I'm proposing you do is you use this as a starting point, you make some changes, and you make it so that it can work on an ESP8266. So that the ESP8266 is going to act like the slave or like the receiver device. So what we're going to do is we're going to save this, and then we're just going to try to run it. We'll try to compile it. We'll see what errors we get, and then we're going to walk through each error, correct each error, and by the end of it, we should have a sketch that's going to work just fine on our ESP8266. Now, maybe this is a bad approach, but I got to be honest, I love the examples that come with the ESP32 for ESP-Now, and I don't think modifying the sketch is all too crazy, so I think this is a reasonable approach. Now, you could probably just search the internet and find some code that's going to work for an ESP8266, but I feel like going through this process helped me understand the differences between how ESP-Now is implemented on an ESP8266 and how it's implemented on an ESP32. But, I could be crazy. All right, so first thing, I'll go ahead and save this. Okay, so I got that. I'm just going to get rid of these comments, and here we are. Okay, so I'm just going to go ahead and try to verify this, and we should get an error. Okay, so the first thing we get is it says, hey, compilation error, ESP_now.h, no file or directory. Okay, so the header file that's used with the ESP8266 is simply ESPNOW.h. Now you might be like, now how the heck do you know that? Well, I know that, realistically, because I was just searching around on the internet and I was just looking at differences between ESP8266 and ESP32 implementations of ESP-Now, and that's really the only difference. If you do go to the documentation for the ESP8266, they have an SDK, and you search for ESP-Now, and you go to ESPNOW API, it says ESPNOW APIs can be found in ESP non-SDK include ESPNOW.h. So, that's one way of getting to the end of that. But anyway, okay, so you got to get rid of, again, that underscore. Okay, so that should fix that error. Now what I'm going to do is try to verify again, and it says exit status 1, compilation error, Wi-Fi.h, no such file or directory. And that's because the Wi-Fi library that an ESP8266 uses is different than the one for an ESP32. So all we have to do is write an ESP8266 Wi-Fi, and we should be good. Let's try verifying that again. Okay, so 2 easy changes. You just change the library header files that we're using. Okay, but it doesn't stop there. We are getting another error. Now, this one is highlighting line 9, and it says ESP-OK was not declared in this scope. Did you mean error OK? So it's saying right here, this thing right here, it has no idea what ESP_OK is. Okay, so what we've got to do is figure out, well, what is ESP-OK? This is like a constant, right? It's all caps. So with the ESP32 library, this must be defined somewhere, but it's clearly not being defined in the ESP8266 libraries. Okay, so if we put our mouse over this, you can see we're getting some information here. And this looks like it's referring to this error OK, right? But we're not interested in error OK. We're interested in this ESP-OK. So what if we come back over to our other Arduino IDE instance, right? So this is the one I've still got the ESP32 connected. I'm going to come down and I'm going to go, look, we've got ESP-OK here. And what I'm going to do is right click on ESP-OK, and I'm just going to peek at the definition. So what this did, when I peeked at the definition, it is taking me to where they are defining the file where they're defining ESP-OK. All right, so this is just a file that's living on my computer right now. This like shows where the file path is, but it's saying that ESP-OK is the value 0, right? That's what it's saying it is. So if I come back over here and I replaced ESP-OK with 0, it would be like the exact same thing. But they're recommending this thing like, hey, did you mean error OK? Well, what if we check out this error OK thing? What if we just type in error OK, right? And now what if we peek here, peek definition. Now this is saying, hey, error OK is also equal to 0. So hey, this should be like a pretty reasonable substitution for us, right? Anyway, that's at least how my thinking is. Okay, so that was one of the errors we had. We've now changed it over, so let's keep going down this path. Again, you might be like, man, this is way too technical. If you just want to grab the code that is going to work, just follow the link in the description. You can go to a page. We'll have all the changed code there for you for this example. Again, it's really not too much. I think there's like 4 lines of code you need to change. But if you'd rather just have this code and you're like, man, this is way too down in the weeds for me, that's cool. I get it. But if you're interested in this kind of thing, then let's go on. All right, so I'm going to go ahead and click the verify button. And now we get the grand poopah of error messages. And I mean, I don't know, if you're anything like me and you see an error message like this, you just start wanting to cry. It's like I got a tissue right now to my eye. Like, I'm just going to go ahead and copy this message and then let's open it up. This is what I'll do. If I get a really complicated error message, or what it at least appears to me to be complicated, I like to paste it in something else and just kind of like analyze it as best I can. All right, so what I've done is I got a split screen here. I took that error message and I just broke it down as best I could, line by line, into kind of each little statement that it was making. But let's go ahead, we'll look at the sketch right here. The line that got highlighted for this error was this function, ESP-Now register receive callback. And let's just take a moment just to kind of talk about what this function is doing. So this function, register receive callback, takes as its argument a different function, right? Which is kind of cool. You've got a function that takes a function as its argument. And as developers, we have to come up with what this function is, but there's some requirements on how we actually make this function. So first, let's talk about what is this onDataReceive function. Well, this callback function right here, whatever we put in here is going to become like the de facto callback function, and it's going to get called when our receiving device receives data. So we have this network, right? There's one transmitter and there's one receiver. And when the receiver receives data from the transmitter, it's going to execute this function right here that we pass into this function. So this is a really important function. Like, you're probably going to want your receiver to do something when it receives a message from the transmitter. So this function in this program is just defined right down here. And here what they're doing inside this function is all they do is print off some stuff. They say, hey, this is what the data that I received, so they just print it to the serial monitor, really not doing too much. I think they also print the MAC address of the device itself. So they're not doing too much in here, but you could imagine this is an important function where you would be executing different tasks based on the data that you receive as the receiver. Okay, so as developers, again, we're the ones responsible for writing this callback function. But when we write this callback function, we have to follow some rules that are defined in this ESP-Now register receive callback function. So this function, ESP-Now register receive callback, is expecting an argument that is going to be a function, and it expects that function to be of a certain design. That is, it expects the function signature to take certain things. So what this error is saying is that we're trying to pass in a function that does not match what ESP-Now register receive callback function is expecting. So it's saying like, hey, I'm expecting a function that's gonna, take these kind of parameters, and you gave me a function that does these type of things. Like, what's up, dude? So it's saying, hey, you're trying to pass me this stuff right here, but I need something that's more like this. Now, if we want to figure out exactly what this function is expecting, we can kind of like dig in like we were before, and we can go to the definition of this. So I'm just going to go to peek definition. And now I'm going to look at where this function, ESP-Now register receive callback, this takes us to the function prototype. And so I'm actually interested in this ESP-Now receive callback. Like, what is this thing that is being defined that I have to match, right? So I'm going to go ahead and right-click that. I'm going to go to the definition of this. Okay, and now, so here is this function that I'm passing in. It has to match this. And so when you see U8, just think to yourself UINT8, or like a byte essentially, right? So this says we're supposed to be passing in an 8-bit pointer to the MAC address, an 8-bit pointer to the data, that's like the data that's actually getting sent, and then an 8-bit pointer to the length of the data being sent. But what are we actually sending in, right? So what are we actually sending in? If we come down to our function on receive callback, so hey, here's a 8-bit pointer to a MAC address, here's an 8-bit pointer to data, and then here's an integer to data length. All right, so the difference here is that these are being qualified as constant. So we don't want those to be constant here. So we can take out the constant, and an integer, just int by itself, is actually a 16-bit space. So we don't want a 16-bit space, we want an 8-bit space, because that's what the function signature was telling us. So now we'll change this over to an 8-bit size. All right, so now we can verify that and we're not getting any errors. I know that's like a really big long description to kind of talk through that, but I don't know if that was helpful or not. Maybe that's just like, you're like, all right, what you smoking, Mike? But that's my take on that. I don't know. Open to your thoughts. Okay, so now our sketch is verifying, and essentially we have a sketch here that can now be used on the ESP8266. It was modified from a sketch that was supposed to run on the ESP32. So I've got one sketch here, this one runs on the ESP32, and then I've got this sketch over here, this one runs on an ESP8266. So of course the end goal here was so that we could get ESP32s working on the same network as ESP8266s. And I hope what I demonstrated here was that there's just some minor changes in how ESP-Now is implemented when you're using an ESP8266, that if you see a sketch that's being used for an ESP32 using ESP-Now, perhaps you'll have enough knowledge about it to be able to make some modifications so that you can make it work for your ESP8266. Now, it might be doing some other things that's only ESP32 specific, which isn't going to work on your ESP8266. But in this case, the sketch here isn't doing anything that an ESP8266 can't do. Okay, so what I've got here is a split screen. On this side is the code we just worked on with the ESP8266, the slave sketch or the receiver sketch, and over here is that master sketch. Now, there is one change I want to make in the master sketch, and it's this channel number. I'm going to change this to 1 because we need to have these both be on the same channel in order to communicate. All right, so now we've got the channels matching, and what I'm going to do is go ahead and upload this code to my ESP32, and I'm going to upload this code to my ESP8266. And then I'll go ahead and open up the serial monitor on this sketch and the serial monitor on this one. So this is the serial monitor for the ESP32, and this is the serial monitor for the ESP8266. The way this default sketch works is it just sends a number that it increments over and over. So now it's sending 5. And now this one is saying, hey, I just received 5, I just received 6. So you can see we have both of these working with ESP-Now. And again, that was kind of the crux of what I was trying to show you, was that you can get an ESP8266 and an ESP32 to communicate on the same ESP-Now network. Hopefully this demonstrated that some. Now, I think in an ideal situation, if you're developing a network, maybe it makes more sense just to have all of the same type of device. You know, like, hey, I'm just going to go with all ESP32s, or I'm just going to go with all ESP8266s, depending on, you know, the needs you might have. I don't think the cost difference is too much between one or the other, so standardizing your hardware probably isn't a bad idea. But in situations like, you know, I've just got tons of different types of ESP boards, like 32s and 8266s, like, and getting those sketches to talk to each other with ESP-Now was a little bit confusing, so I thought hopefully this could help shed some light on that. Well, thanks so much for watching. I really appreciate it. If you haven't subscribed to the channel yet, please do. Like this video. If you have a ton of questions, please feel free just to ask them in the comments. Or if you have some ideas for what would make a fantastic video on this channel, just leave it in the comments. We really take a look at those to help guide our future videos. Also, feedback in the comment on the video is much appreciated. I have thick skin, so I'm happy to hear all of your thoughts. And I want to say finally, if you're watching this, but maybe you're not sure on some of the just like the basic programming stuff, you're not feeling super confident there programming with Arduino, then I highly recommend you check out Programming Electronics Academy. There's a link in the description below. That's our training membership site where we have a bunch of courses and a forum on really helping people understand these core Arduino programming ideas. Kind of walks you step by step, starting at the very basics and really helping you understand how to code and how to code with Arduino. All right, have a great one and take it easy. Bye.